Hello everyone, this is not your chem tutor and this video is part 3 of our series on balancing nuclear reactions. In this video, we will talk about the types of radioactive decay. So please take note that we are only going to discuss some of the most common types of decay that you are going to encounter in general chemistry subjects. But before you continue this video, make sure you have watched part 2 of the series. If not, then you can click the link in the description box. In part 2, we discussed about isotope notations. So you need to understand isotope notation because in this video, you will be seeing a lot of them. Okay, so without any further ado, let's go straight into the discussion. First, let's talk about the definition of radioactivity. I'm pretty sure you have heard of the term, or if not, maybe you heard about radioactive chemicals or radioactive substances. In nature, there exists what we call unstable isotopes. These isotopes are unstable because of the proton-neutron ratio in the nucleus of the atom. Now, I will discuss about proton-neutron ratio in a separate video. For now, let's just focus on the fact that whenever something is unstable, it wants to achieve a more stable form, right? And in order for these unstable isotopes to become more stable, they undergo radioactivity or radioactive decay. So in the process, these nuclei spontaneously emit particles and or electromagnetic radiation. So that's our definition of radioactivity or radioactive decay. So let's take a look at this example. We have here plutonium-239, which is an isotope of plutonium. As you can see in the nuclear reaction, plutonium-239 emits this kind of particle. And later on, when we discuss about the different types of particles and different types of decay, you would know that this is what we call an alpha particle. So, when plutonium-239 emits an alpha particle, it forms another nucleus, which is uranium-235. Now, uranium-235 is what you call the daughter nucleus. It is the nucleus produced by the radioactive decay. Plutonium-239 is what you call the parent nucleus. So it is where the daughter nucleus comes from. Okay? So now we have discussed the definition of radioactivity. Let's proceed now to the different types of particles that you will encounter in radioactive decays. Now, here is a list of the common types of particles and radiation emitted in radioactive decays. So what's important here is that you memorize the symbol for each type of particle or radiation. So let's go through each of them quickly. So for alpha particle, the symbol is that of the helium-4 isotope. Or in other references, instead of helium, they use the Greek letter alpha. Anyway, they're just the same thing. You can use either of these symbols. For beta particle or electron, you can use either the Greek letter beta or the small letter e. Again, they're just the same thing. The third one, positron, looks similar to that of the beta particle. However, the key difference is that for the beta particle, the number below is -1. For positron, it's +1. Again, you can use either the Greek letter beta or the small letter e for positron. It's just the same thing. Let's move on to the proton. For proton, you can use either the small letter p or you can use the elemental symbol for hydrogen, which is capital H. They're just the same thing. For neutron, we use the small letter N. And for gamma ray, we use the Greek letter gamma. So in this list, there are 5 particles and 1 radiation. So the particles are your alpha particle, beta particle, positron, proton, and neutron. Gamma ray is not a particle because as we know it, gamma ray is a form of electromagnetic radiation. Okay? So now that you know the common types of particles and radiation, we now move on to the types of decay. Okay, so as you can see in your screen, we have here some of the common types of radioactive decay. So for this video, I will only give you a brief description of each type of decay because in the succeeding parts of the series, I will make a separate video for each type of decay. So there, I will be discussing more in details. But for now, I will just provide you with brief descriptions. So let's start with alpha decay. This is also known as alpha production or alpha emission. So your parent nucleus emits or gives off an alpha particle. So you can see an alpha particle on the right side of the reaction. Beta decay is also known as beta emission or beta production. So your parent nucleus emits or gives off beta particle or an electron. So you can see a beta particle on the right side of the reaction. For positron decay, this is also known as positron production or positron emission. Your parent nucleus will emit a positron. So on the right side of the reaction, you will see a positron. Next is gamma emission. So for gamma emission, you have a nucleus at a higher energy state. So how will you know that a nucleus is at a higher energy state? It is symbolized by this asterisk, or in some references, they put the letter M, small letter m, beside the mass number. So whenever you see an asterisk or a small letter m beside the mass number, that means that your nucleus is at a higher energy state. So when that nucleus undergoes gamma emission, it emits, of course, gamma rays. So you will see gamma rays on the right side of the reaction. Okay? Next is electron capture. So by the term itself, electron capture, the atom captures an electron. So the atom gets an electron. So you will see an electron on the left side of the reaction. And in many cases of electron capture, it also produces gamma rays. So in electron capture, you can also see gamma rays on the right side of the reaction. And lastly, we have spontaneous fission. In spontaneous fission, you have a heavy nucleus. So this is a heavy nucleus. And it splits into, so your heavy nucleus splits into lighter nuclei. So as you can see, uranium-235 splits into 2 lighter nuclei. We have barium-139 and krypton-94. And in many cases of spontaneous fission, neutrons are also produced. So as you can see in this example, 2 neutrons were produced in spontaneous fission. So here are the common types of radioactive decay. So you just need to familiarize yourself with the format and how these types of decay are written. So if you're good with this, then we can answer some exercises in the next slide. So for the last part of this video, we will just have some exercises. We need to identify the type of nuclear decay. So we are given here 1, 2, 3, 4, 5, 6 examples. So we just need to figure out what type of decay in each example. So for the first one, you can see an electron on the left side. and it also emits a gamma ray. So obviously, from what we discussed, this is electron capture. Second, we have an alpha particle on the right side, so this is alpha decay. For the third example, we have a nucleus at a higher energy level or energy state because of the asterisk. Then it emits a gamma ray. So this is gamma emission. Next, the reaction produces a positron. So this is a positron decay. Next, a beta particle is emitted. So this is beta decay. And lastly, we have a heavy nucleus and it splits into two lighter nuclei plus neutrons. So based on our previous slide, this is obviously spontaneous fission. So these are the answers. I hope you got all of them correctly. And now, let's move on to part 4 of the series.